Hi guys, hope all of us are doing fine. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome each and every one of us into my discussion for today. Now I'm going to look at the concept of the Argand diagram on what we refer to as a complex plane. Now this is going to be of course a culmination of the previous discussion which we have had on various ways of representing complex numbers. And in a sense, of course, I've just given in those specific videos an equation that represents the concept or how we can define a concept of a complex number, and in some of the representations which basically constituted the imaginary and the real parts of this specific representation for a complex number. Now, in that previous discussion, basically we had mentioned that we can represent a complex number using this analogous form of the xy plane, whereby, as we said, this is going to be forming the x component, or x-axis is going to be forming of course, the real part or the real component of an imaginary, of course, or a complex number, which can be given in terms of a phasor z. And we're going to see that the y component is going to be representing an analogous form of this specific representation of the phase of z, which is going to be giving us a complex number. Now, in this particular case, I said that we can have this phase of z represented by this specific aspect of that, of course, graph, whereby we said that we are going to have an, of course, a section for this specific imaginary part given as such, and we're also going to have this specific section for the real part given on the x-axis as shown as such. Now, in this specific discussion, I'm going to be extending this specific representation, and we're going to have this general part of the phase of z, which we had defined in terms of that particular representation, which basically in terms of a complex number gave us this particular set of what we refer to as a real and imaginary component of this specific, of course, aspect of the complex number. Now, in a sense, we're going to see that we can be able to give additional information on this specific part, whereby we consider this range of angle which has been extended between this real axis and, of course, this phase of z, which can be given in terms of theta. Now, therefore, then for us, we are going to be using the concept of a Pythagoras theorem in some aspect, or trying to find these particular quantities which we are going to refer in terms of the modulus. Now, if we are going to have this one, then we can refer this one as the modulus of this complex number, or the modulus of this phasor of z, which represents a complex number. So this can be given in terms of this representation, which is going to be having those specific signs. Now, from Pythagoras theorem, we're going to see that if we're going to have this particular x and y component, then therefore we can use Pythagoras theorem for the right angle of these specific components. And this is going to be given in terms of the root of the square of x plus the square of y given as such. And that is going to be forming what we refer to as the modulus of this complex number, or the absolute value of z. Now, the angle between, of course, which is going to be this real axis and this phase of z, can be given in terms of theta. And in this case, from our trigonometric ratios, we can define this aspect of theta by having it as the tan over theta is going to be given in terms of this particular range of the imaginary part over the real part given as such, which is going to be given in terms of y all over x. Therefore, we can find this angle by finding the tan inverse of this specific range of value over x over y, or ratio over y over x given as such. And this is going to be forming a positive angle between this specific range of real part and the of course, this particular phasor of z, which we have given in terms of the magnitude or the modulus of z given as such. And this is going to be, of course, representing what we call an amplitude or argument over z. So therefore, this is going to be referred to as, so I've defined the two basic terms for the modulus, which can be given using this specific evaluation. So the angle between this real, of course, axis and this phasor, which we have given in terms of z, can be given as a modulus, which is going to be given in terms of r. So therefore, we have said that we are going to define this specific aspect of the angle between this specific axis and this one given in terms of theta. Now, this theta is going to constitute what we refer to as amplitude. Now, in our previous discussion, we have looked particularly for sinusoidal waves and other forms of course, waves, what we refer to as amplitude, which is going to be the maximum displacement from equilibrium position. And in this case, we're going to consider this specific aspect of theta, which is going to be the angle between this axis and the phasor. And this is going to be representing what we refer to as amplitude or argument. So we're going to have this one given in terms of argument of this specific complex number given as that. And this can be given in terms of perhaps a short form which is going to be represented as such. So in case we come across this specific representation in some of our videos, then it's going to be representing the argument of a z or the amplitude, which is going to be given in terms of a theta. And those are going to be two basic concepts which we have just learned from this specific, of course, representation, which is going to be occurring in what we refer to as a complex plane. Now, this as well is going to be referred to as the Argand diagram representation of that specific complex numbers. And in this case, we're going to have a restriction for our specific angle or argument, which we have given in terms of theta, whereby we're going to see that theta basically is going to be for us, we can restrict this specific aspect of theta between the values of 0 and 2 pi, which if we represent on the, of course, a plane, this can be given in terms of, so let's just have this one given as such. So we're going to have this theta, which we have defined in terms of an argument for us being represented by the, so we can have this one given in terms of pi. And this is going to be starting from this specific range of values going this in this anti-clockwise position. Now that we have considered theta to be an angle that can be extended from this specific real axis given as such, then therefore that's going to be restricted within this specific range which I've just given on the board. Now in our subsequent videos, we are going to look at further evaluations and of course some of the definitions which we are going to come across, especially under the concept of a complex number. And in this case, I assume that we have understood how we can, of course, define that complex plane which I've given in terms of those particular representation, which has given us the modulus and a representation for the argument. So kindly check our description boxes for various links of other videos. Engage us in the comment section and also ring that notification bell for other updates on these topics and a similar discussion. So that is it for now, guys. By God bless you. Catch us in our next video.